Physical Science. This is Mr. B, and we are going to wrap up Chapter 15 with this video today. And the focus of this video is going to be on energy resources. Up to this point, we've talked about energy kind of on a smaller scale, just within everyday objects and things like that, and how it's transferred in everyday life, things like that. But energy also has a much larger application. It's present in our everyday lives, and it's responsible for making our life kind of the way that it is, kind of the ease of our life with electricity, heating our houses, heating our water, things like that we use energy for. So it's not just, we can't just take a look at energy in terms of how it's transferred in our Rube Goldberg machines, but we can also take a look at energy on a much larger scale. So for our first, again, our example here is crude oil is pumped out of the ground, refined, and turned into gasoline, fuel oil, and other products. And that's one of our main sources of energy is crude oil. We use it for our automobiles and then other things like that, and especially around here like different farming machinery. So crude oil is a big source of energy for us around here. And that's going to take us to our first type of energy, which are non-renewable sources of energy. And what a non-renewable energy resource is they exist in limited quantities, and once used they cannot be replaced except over the course of millions of years. So once we use up a non-renewable energy source, it is never going to be able to come back unless it's over the course of millions of years, and none of us are going to be around to see that. And some examples include oil, natural gas, coal, and uranium also is a non-renewable source of energy. So oil, natural gas, and coal, maybe you've heard of these before, are what is known as fossil fuels, so I definitely write that down. And they were formed underground from the remains of once living organisms. So that's why they actually call them fossil fuels, because basically what happened is there was a bunch of, just take like a bunch of dead plants, and they all got buried under some type of under something. They were buried, they were compressed, and over time they formed these fossil fuels. That's pretty much the simplest way to break it down. So they were once living organisms, so they were called fossil fuels, and they account for the great majority of our world's energy use. We are pretty reliant on fossil fuels for almost all of our everyday energy uses. And these fuels are not distributed evenly throughout the world. Some parts of the world don't have access to the same amount of fossil fuels as other places. And you can see that it's probably not going to be a good thing, because if it's a non-renewable energy source, that means it might be running out sometime within, who can say. So non-renewable energy resources are good, but they're non-renewable. They're not going to be here forever. So we might want to focus our attention on some of the major renewable sources of energy, and these are resources that can be replenished or that can be replaced in a relatively short period of time. And these are the types that we're going to talk about. There's hydroelectric, solar, geothermal, wind, biomass, and possibly one in the future is going to be known as nuclear fusion. So that's going to be one that's kind of more theoretical at the moment. It's not really set in stone yet. So most renewable energy resources, either directly or indirectly, originate from the sun. So the sun, again, big driving source, it's our main source of energy. So all of our renewable energy resources most likely are going to originate in some way from the sun. The sun and the earth both are constantly releasing large amounts of energy, so we kind of just need to figure out a way to harness it, because this energy could be used for generating electric power, heating buildings, or other purposes. So like I said, those non-renewable energy sources, they're not going to be around forever. So maybe some of these can be explored to be used more widely here. So our first type of energy, definitely write this down, is hydroelectric energy, and it is obtained from flowing water. As water flows downhill, its gravitational potential energy is converted into kinetic energy, and then that kinetic energy is going to turn turbines connected to electric generators, and therefore it's going to convert it into electric energy. I think some of you kind of took a look at one of these examples when you were doing your energy conversion in everyday life. So hydroelectric is water flowing downhill. And most hydroelectric plants rely on dams that are built across rivers in order to harness this power. There are some big advantages to this type of energy. It's very low cost to produce, and it does not pollute the environment. So those are two pretty big pros. However, they can cause a other variety of environmental problems. We're going to take a look at that more in class, but hopefully maybe you can think about this before we get to class. Like if you build a dam across a river, what's some problems that's going to cause to the environment? So hydroelectric energy has its advantages, but also one of the big drawbacks is it causes some big environmental issues as well. And the Hoover Dam is one example, and it was built across the Colorado River on the Arizona-Nevada border, and it's 221 meters tall, and it can generate over 2 million kilowatts of power. So there is an energy source possibility here, but maybe you can see another drawback is we don't have huge rivers everywhere, so it's going to be kind of limited to the point to where we can make effective hydroelectric energy sources. So that's our first type of renewables, hydroelectric. Our next one is solar energy. Sunlight converted into usable energy is called solar energy. And we have two types of solar energy. We have what's known as a passive solar design, where sun heats a building without using machinery. So this is just if you have a lot of windows, you open up the windows on a sunny day, the sun's going to come in, it's going to heat up whatever it is in. So that's passive solar design. So that's basically can be done by anyone. And then our other type, an active solar energy system, sunlight heats flat collection plates through which water flows. So that's actually how a solar panel works. The energy is absorbed, then it heats up water, and then the water is going to trigger some other energy reactions as well. And sunlight can also be converted directly into energy by means of solar cells, which are known as photovoltaic cells. So I'm not going to really need to memorize that, just probably maybe jot that name down. That might pop up again, that this is kind of a more direct form. Rather than heating up the sunlight, these cells are going to convert it directly into the energy. And a few large solar electric plants use mirrors that concentrate sunlight to produce electricity. And so, again, trying to figure out other ways to maximize the amount of energy they can get. And the benefits of solar energy depend on the climate. Obviously, if you're in a very cloudy, rainy region, solar energy is not going to be a very practical thing for that area. So solar energy, again, is another thing. Kind of depends on where you're at and how effective this renewable energy resource can be. And so our next one is geothermal energy. So we have had hydroelectric, solar, and geothermal. And this is thermal energy beneath Earth's surface. So this is energy that's produced naturally by the Earth. And in some regions, especially near volcanoes, this can actually be used to generate electricity. This energy does not pollute, but however, if you notice we don't have volcanoes everywhere, it's not widely available. So it has to be a very certain specific spot for geothermal energy to work. And that's why you're going to take a look at that in class, maybe find some places in the world where geothermal energy is actually being used. And so here is a couple pictures of a couple examples of our last two of solar energy. So there's a solar electric plant that uses the solar cells to convert sunlight into electricity. So that's A. So this is what a solar electric plant might look like. And this is a geothermal plant in California that's actually using geothermal energy from the Earth to generate electricity. So natural heat, the thermal energy that comes out of the Earth, can be harnessed to be used for electricity. And a couple other renewable resources is one that's known as biomass energy, and this is the energy that is actually stored in living things. So we all have energy stored in us, and you'll learn next year that bio means life, so that's how you can kind of tell that's the energy of living things. And this can be converted directly into thermal energy or converted into high energy alcohol fuel. So ethanol is an example. So right now, if you have any farmers in your family, they might be selling some of their corn to different plants that are using ethanol, and that's again going to be an alternative to gasoline. And then another renewable source is what's known as a hydrogen fuel cell, and this generates electricity by reacting hydrogen with oxygen. These cells can be used to convert energy from renewable resources as well. This is kind of just like a little supplementary thing that could be used in association with some of our other renewable energy sources. And another renewable source that might be our future source of energy is nuclear fusion. So this is actually the process that goes on in the sun where we merge two hydrogen atoms together, and This process will probably produce little pollution or radioactive waste, and that's why scientists have been working on this for many years, but there's still many challenges remain. It requires a massive amount of energy if it's done inside the sun to actually carry this out, and so it's hard finding a stable enough environment here on Earth to carry this process out is going to be challenging. So nuclear fusion is probably where our future of renewable energy is if we can ever find a way to sustain it on Earth here. And to wrap this up, we're going to talk about how energy resources can be conserved, because like I said, we're focused mainly now on non-renewable energy sources. So what can we do to conserve our energy resources? So energy resources can be conserved by reducing the needs that we have and by increasing the efficiency of our energy use. So finding ways to use less energy or to use energy more efficiently is known as energy conservation. So simple things as making appliances, cars, and even light bulbs more energy efficient is a way of reducing our energy use. That's a big thing going on right now. All of your light bulbs now, probably hard to find anything that doesn't say high efficiency that can last much longer. It doesn't use as much energy. Those are things that are going to become requirements probably before too long. And energy efficient purchases will often cost more initially, but they can save money and fuel costs over time. I know this from personal experience. I had to put a new heating and air conditioning system in my house. The higher efficiency ones cost more money. However, I've noticed my bill has gone down drastically since installing this, so I might have paid more up front, but over the course of the next several years, hopefully for most of the rest of my life, my energy bill is not going to be as much, so it's going to basically pay for itself. And another example of kind of conserving our energy resources is using mass transportation system like trains, buses, and streetcars. And again, if we use this mass transit, it could reduce energy use, because again, that's one bus taking multiple people to work instead of all those people driving their own cars and things like that. So know this video was a little bit longer, but I figure one night of homework is better than two if it's a little bit longer. So that's it for this video. That's it for this chapter. Let me know if you have any questions.